Hello, Trigonometry student. This video is video number 3 for 10.3. Our primary goal is to learn how to convert equations from rectangular to polar and then also from polar to rectangular. I don't have a how to here, but basically we use actually the same formula that we use to convert between coordinate to uh, between the two coordinate. So that means if you have an equation that is x and y, you would um, you would calculate you would replace it with r if you see x squared plus y squared, and you would replace it with theta. You you would replace r cosine theta by x and r sine theta by y. Okay, so basically like this. So, and when we say a polar equation, so primarily all polar equations are written in like R equal form. So there are some special situation where a polar equation would be written in theta equal, but that is really rare. Um, yeah, most of the time is R equal something. So when we say we write something in a polar equation, you would replace everything. Yeah, the how-to will be we replace all the x. Let me write it here. Replace x by r cosine theta. Replace y as r sine theta, and then replace any x squared plus y squared as r squared. So that is kind of the strategy for rectangular to polar. So this is the strategy for rectangular to polar. Rectangular equation to polar. So after that, you solve rectangular to polar. And then after that, you solve R equal. So kind of the steps. It's like this, the first step, and then this is the second step. So these are the two examples. I have an equation that is x squared plus y squared equal to 9. I don't know if you learned it before. This is actually a circle. Whenever you see x squared plus y squared equal to a number, it's a equation of a circle. What's the radius of the circle? The radius of the circle is 9. Oh, no, the radius of the circle is square root 9 equal to 3. So how do I convert it into a polar equation? I see x squared plus y squared. So I convert this as r squared equal to 9. And then I solve for r equal. So how do I get r equal? I square root both sides, right? So then you do square root both sides. Let's do this. Because the equation, the final equation of a polar equation is always in terms of r. So r equal to 3. See, this is a circle. It's quite complicated. It's x squared plus y squared equal to 9. But in a polar axis, polar grid, you graph r equal to 3. That makes sense because r equal to 3 is the circle with all the distance from the pole is 3, right? So it's there the same thing. What about this line? Y equal to 3x plus 2. So this is, I know, we know this is a line. So this one is a circle, right? So you didn't change the equation, just write it in different form. This one is a line. So with the y-intercept 2, and then you do a like this, right? So how do I change it into a polar form? Remember, whenever I see y, I write it as r sine theta. Whenever I see x, I write it as r cosine theta. So now everything is in r and theta. So that's step 1. Now I want to solve for r. So, but r is in two different places, so I can't like just divide by sign because I have to have r all on one side. So what I'll do is I put I minus 3r on both sides, 3r cosine theta minus 3r cosine theta on both sides. So it's become r sine theta minus, erase this first, minus minus 3r cosine theta equal to 2. And then I factor the r out. Sine theta, this is r. Minus 3 cosine theta equal to 2. And then I divide these things on both sides. So r will equal to 2 over sine theta minus 3 cosine theta. So this is a very complicated kind of equation, a polar equation, but it's the same as a line. Okay. So that's how you do it. What about convert it back? So if someone gives you a polar equation, how can you convert it into rectangular form? So the strategy would be step 1. Whenever you see r, you replace it with square root of x squared y squared, right? And whenever you see r sine theta, you replace it as y. And whenever you see r cosine theta, you write it as x. What about if I only have cosine theta? What you do is you just multiply with r. So sometimes you can do it. So and then if it's a theta, so what do I do? So you can say tangent theta equal to the tangent of the other side, right? Tangent of the other side. So and then evaluate it. So these are the strategy. And then I think, and then you just, you can write it as the step 2 would be write y equal, right? If needed. Okay, so let's do r equal to 3. So r is square root of x squared plus y squared. I don't have any theta or so I just write it this way. Equal to 3. And then I don't like the square root. I would just do 6 squared plus y squared both sides. This is not very good. So I square both sides. So become x squared plus y squared equal to 9. So this is the same as what we did last one. They're both a circle of radius 3. Second one, be theta equal to pi over 4. We say if there's theta, we can change into x and y, right? So it has to be sine or cosine theta. So the first things we start off would be tangent both sides. But tangent theta is sine theta. So our ultimate goal is to have sine and cosine comes out, right? And tangent pi over 4 is 1. Now, I don't have any x and y to replace, so I multiply r on both sides. So because we actually want r sine and r cosine, so that's really good. Oh no, I don't need to multiply both sides. I just multiply r top and bottom, right? It's the equivalent fraction. So then that would be r sine theta over r cosine theta is y over x, right? R sine theta is y equal to 1. Make it nicer, y equal to x. So this is a line that goes through the, just a line that goes through the origin, y equal to x. Is the rectangular equation. What about r equal to 2 sine theta? Wow, this is I can almost replace this by y if I have r on this side. So the way to do it would be I force r on both sides, which is good because this would be r squared. And this is I have 2r sine theta, right? So r squared is what? It's x squared plus y squared. And r sine theta is y equal to 2y. That's the equation of another circle. In pre-calculus, you'll learn that this is another circle. Okay, how about this one? R equal to 3 over 1 plus 2 cosine theta. This one is a little more complicated. I see a cosine here, but there is no r. So the plan is to multiply this by both sides by 1 minus 2 cosine theta. Left and right, left-hand side and right-hand side, right? So that so these two cancel. I would have r minus and then distribute, right? My r minus 2r cosine theta. The goal is to have this r cosine theta show up equal to 3, right? So r cosine theta was x, so that's really good. And then I would just say subtract on this side, r equal to or add the 2 cosine theta back over here. So this would be square root of x squared plus y squared because there's no way around it, right? And then the other side would be 3 plus 2x, right? R cosine theta is x, and that's the rectangular equation. You start when you have everything in x and y. Okay, so that's a general idea on how you can convert equations to rectangular and polar. So the last part is to how to graph a polar equation in a graphing calculator. So there is all these 3, or actually the theta I can graph, but A, C, and D I can graph it in a graphing calculator to see what it look like. So let's see how to do it. So get your TID4 out, and I have a online one here. Turn it on. Oh, clear this first. The first thing you need to do polar graphing is change into polar graphing. So press mode, just mode, and then you will see that you have to make sure that your degree and radian is blinking on radian. And then normally by default, you're graphing in function mode. Function mode means rectangular coordinate. You want to cursor to the right side until it's blinking in the polar mode, POL for polar. And then press enter to select polar mode and exit second mode, which is quit, so exit out. So make sure that you select polar and also radian, exit out. And then to graph anything, you press y equal. So this will show up. So the first equation I want to graph is r equal to 3, right? So if you look at this, the first one I want to graph is r equal to 3. So you would just say r equal to 3 here. And then you do sum square, because you want it to be in a square form. So that is how it is. Yours may be a little different, maybe a smaller one, because I have adjusted my windows. So if you go back to here, you can say the windows, so don't change the theta, but you can change the x minimum to -5 or -3 to 3, and then to 5. So the x would be a little bigger, and then you graph again. Wow, no. Sum square 5, would it work? Yeah, this would be better. Sum square. After you adjust the window, so this would be a circle. So see how the equation is so easy. R equal to 3, it becomes a circle that is sum 5. That is 5 away from the pole. Okay. So let's graph another one. The other one is let's see, R equal to 2 sine theta. Okay. 2 and then sine theta. Where's theta? Theta is the xt theta things. If you press, the theta will show up because they know that you're doing polar graphing. So 2 sine theta, and then you just do sum 5. See, it's a circle. Is it a circle? 2 sine theta. I think it's a circle. How come it look like that? Don't know. But this presumably is a circle. Let's try this very complicated one. R equal to 3 over 1 plus 2 cosine theta. Okay. R equal to, what was it? 3 divided by, well, let's clear this first. 3 divided by, open parenthesis, what? 1 minus 2. 1 minus 2 sine theta. Is it sine theta? Or is it cosine? Oh, cosine. Delete cosine theta. So close it and close it. So then we do sum 5. Whoa. Oh, it is a kind of like a hyperbola or something. Very interesting. So so this is how it look like for polar graphing. You can instead of sum 9, you can do graph after you adjust the window, but most of the time you do sum 5, not sum 9. Sum 5. This one is kind of interesting. Okay, so this is all for 10.3, and I hope